The first example we're going to look at involves using these identities we've been talking about to find values for specific trig functions given a value for one of our trig functions for the angle. So first of all, we want to look at the information that we have and the information that we're trying to find and determine which of our identities we might be able to use in order to do that. So let's start this problem by just picking one of these two functions that we're going to try and find the value for. So let's start by finding just cosine of theta. Because if we know sine theta and we have cosine of theta, then we can find tangent of theta. But let's start with this part of this one. So the question we want to ask ourselves is, which of our identities involve only sine of theta and cosine of theta? So we're going to look through our three Pythagorean identities and our two quotient identities. Out of all of those, the one that involves sine theta and cosine theta and nothing else is our first Pythagorean identity, which is sine theta squared plus cosine theta squared equals 1. If we use this one, we can substitute in the value that we know for sine of theta, and then we can solve the equation for cosine of theta. So let's do that, but first we're going to rewrite this with the exponents on the outside. Just so that it's more clear where we're substituting in values. So now, in place of sine of theta, we're going to substitute in the value we were given, which is negative 4/5. Oops. Sorry, that was supposed to be an equal sign up there. So now we have an equation. We want to solve it for cosine of theta. The first thing we need to do in order to get there is to solve it for cosine of theta squared. So we want to go ahead and square our value here. So if we square the top and the bottom, we would get positive 16 over 25. Then we're going to subtract the 16 over 25 from both sides. If we get a common denominator on this side and then do this subtraction, we will end up with 9 over 25. Now we've solved it for cosine of theta squared. Now what we would want to do is take the square root of both sides so that we end up with just cosine of theta over here. And normally when we do that to solve an equation, on the side with the number, we have to do plus or minus because there are two possible solutions to this equation. So to determine which one of those is going to be correct for this particular situation, we have to go back and look at the information we were given, and that was that cosine of theta is greater than 0. In other words, cosine of theta is supposed to be positive in this problem. That means when we're doing the square root of both sides, we'll just take the positive value of the right side of this. So we don't have to worry about the negative because we were told that this value is supposed to come out to be positive. So here, these two are going to cancel each other out, and we just get cosine of theta. The square root of 9 over 25, the positive square root is going to be 3/5. So there's our answer for the value of cosine of theta. Now the next thing we were supposed to find was tangent of theta. Now we know the value of sine of theta and cosine of theta, so we can use our quotient identity that says that tangent of theta is equal to sine theta over cosine theta. We're just going to take our values for sine and cosine and substitute those in. So sine of theta is negative 4/5. Cosine of theta we just found was 3/5. Again, we can take the denominator of this, invert, and multiply. So we'd have negative 4/5 times 5/3. The 5's cancel out, and we end up with negative 4/3. So now we found the answers to both questions. Let's look at another example. Again, in this one, we're trying to find the values for two different functions. We're given the value of cotangent of theta, and we know what quadrant theta is in. So let's pick one of these two values that we're going to find first. And just because it's mentioned first, let's start out by finding sine of theta. So what we want to ask ourselves, is there an identity we have that involves sine of theta and cotangent of theta? And only those two. The answer is no, there's not an identity that only involves those two. One thing that we could do is pick one of these two and use the reciprocal of it instead and see if there's an identity that involves those two functions. So let's look at the reciprocal of sine theta, which is cosecant of theta. So we're going to ask the same question. Is there an identity that involves cosecant of theta and cotangent of theta? And yes, there is actually one that involves these two, and that is cotangent theta squared plus 1 equals cosecant squared theta. This was one of our Pythagorean identities. So let's try using this one. Again, we're going to start out by rewriting this so that the exponential form is a little bit more clear. The value that we have is for cotangent of theta, so we're going to substitute that in here. If we square the negative square root of 3, we're going to get 3. So we end up with 4 for the value of cosecant theta squared. Again, we would want to take the square root of both sides to solve this. So we're going to have to figure out whether cosecant of theta in this situation is going to be negative or positive. So let's go back to the information in our problem. It said that theta is in quadrant 2. In quadrant 2, remember, the function that's positive is sine. That means that cosecant is also positive. So in quadrant 2, sine theta and cosecant theta are positive. So when we do this and take the square root of each side, we're just going to take the positive square root on this side. So those two cancel each other out. The square root of 4 is 2. So we find out that cosecant of theta is equal to 2. Now what we really wanted to find was sine of theta. Remember, sine and cosecant are reciprocals of each other. So that means sine is the reciprocal of cosecant, which would be 1/2. So we've got our value for sine of theta is equal to 1/2. Now we want to find this other value, which was for cosine of theta. There are a couple of different ways we could do this. Since we know the values for cotangent and sine, we could use one of the quotient identities, or since we know sine, we could use a Pythagorean identity that involves sine and cosine. Let's use a quotient identity, and that is that cotangent theta equals cosine theta over sine theta. We're going to substitute in the values that we do know, which are that cotangent is negative square root of 3, and sine we just found out is equal to positive 1/2. And we're going to solve this for cosine of theta. It means we want to multiply both sides by 1/2. So over here the 1/2s cancel each other out, and on this side we end up simplifying this to negative square root of 3 over 2.